The irrational numbers. Let's start with some descriptions. Irrational number. Irrational numbers are all of the real numbers which are not rational numbers. Rational numbers. A number which can be expressed as the quotient or fraction of two integers, a numerator p and a non-zero denominator q. Integer number. An integer is a number which can be written without a fractional component. The set of integers includes 0, the natural numbers, and their additive inverses. Natural numbers. Natural numbers are used for counting and ordering. When we started arithmetic addition, we were using the natural numbers, which can be denoted with this boldface n. By my account, I would say the objective standard for the definition of n should not include 0. 0 is the absence of an object and cannot be counted. The object itself can be counted because it can be seen as a unit member of a group. Let me rephrase to make this clear. To an adult with basic math training, one may try to argue that they can count to 0 or count the lack of something. But don't allow poorly thought out phrases to guide your mathematical understandings. The purpose to counting is to keep track of objects, more specifically, to keep track of a specific kind of object. For example, before the advent of writing numbers down, people needed to track the number of sheep they were herding. 1 pebble for 1 sheep. 1 being a pre-number type of number. It's simply the recognition that this is a pebble, a member of a group of earthly hard pieces of ground, and this is a sheep, a member of a group of living woolly beasts. The discovery of 0 comes after the discovery of a member of a group, and after the discovery of a group existing of more than one. 0 is not something, and therefore it is not something you count. That said, we can doodle the sets of numbers as such. First we have the natural numbers, n. Since integers, z, use natural numbers, 0, and the negative natural numbers, it encompasses n. Rational numbers are fractions of integers, so it surrounds z. The irrationals, p, are everything else which are not rational. The whole set together are called the real numbers. To put this into simpler terms, natural numbers are words that you use to describe the quantity of objects or the order of them. They start at 1 and increase 2, 3, 4, 5, 6, 7, 8, 9, and rolls over to 10, the 0 having merely represented the quantity between 9 and 11, and then continues to count as before. Integers are kind of like when you owe a gang money you don't have, living as if you had negative money. In a situation like this, one might be happy to have no money at all, or 0. Rationals are when you divide what money you do have amongst your expenses. All rationals take the form of the ratio of two integers. Irrationals cannot be written as fractions or ratios like rationals can. 4 examples of irrational numbers are pi, e, phi, and square roots of any natural numbers besides those that are perfect squares. All irrational numbers, when written in decimal form, the decimals do not terminate nor end with a repeating sequence. Numbers with decimal expressions that terminate or repeat can be expressed in fractional form with 2 integers. For example, the number 0.666 repeating. If you take the variable x and assign it the number 0.6666 repeating, you could times both sides by 10, so 10 times x equals 10 times 0.6666 repeating. On the left-hand side, you just get 10x. On the right-hand side, you get 6.666 repeating. Since we know that x equals 0.666 repeating, we could minus an x from both sides, such that we would have 10x minus x equals 6.666 repeating minus 0.666 repeating. What we'd be left with, on the left-hand side, 9x. On the right-hand side, we'd be left with 6. Therefore, x is equal to 6 over 9, or 2 over 3. In order to solve terminating decimal forms, such as 3.5, we can just split that up into 3.0 and 0.5. This would get us 3 over 1 and 1 over 2. We could get rid of the fraction by timesing both numbers by 2, such that the 3.0 will get us 3 over 1 times 2, which is 6. The 0.5 will be 1/2 times 2, which will be 1. If we add them back together like they were, we would get then 6 plus 1, which is 7. If we then get rid of the 2 that we timesed in to get rid of the fractions, we would get 7 divided by 2, which is 3.5. Numbers like pi do not terminate nor repeat. They go on forever without repeating a pattern. Why does this happen? Simply put, if we create numbers to represent a quantity and devise a system to count not just the objects, but also the fractions we could divide them up into, we must introduce irrationals. Say we have 22 apples and we divide them up among 7 people. Each person gets how much? A real number is a number on the real number line. So in order to have 22 over 7, which gets us about 3.142, we must also have a number like 3.1419, which means that there must be a number before that, like 3.14159, and so on and so on. Because you can always add one more number, most numbers that are not whole, can always add more numbers. Irrational numbers are a natural result of the decimals of fractions of natural numbers. You cannot get to 22 over 7 without passing pi. But if we didn't use decimals, we'd stop at 22 over 7 as 22 over 7. But decimal expression gives us irrationals. We will explore some irrationals that occur as a result of higher levels of math in the next video. Don't forget to subscribe to the channel, like and share the video, and support us at patreon.com/youexist. See you next time.